number for the first period.
That's what I said.
Maybe.
Is my voice like a dog whistle? Isn't that exactly what I
Yeah,
said?
no.
What?
All right, follow along. Help me out here so that we can record this. Problem, I'm going to run through just a bunch of these real quick. We'll skip one here and there. You might want to, when we get to 38, you might want to write it down so it's in your notes there. Maybe on Tuesday, if Jesse isn't here, maybe I'll let you use your notes. If he is here, we're not using our notes because he's annoying me today. So, but if he's absent, then the rest of you get to use your notes, and then he won't be able to when he comes back to retake the test. But I might let you use your binders on the test. Number 16. What kind of angles are 1 and 2? Supplementary. If angle 2 is 67 degrees, how do you find angle 1?
Minus it from 180.
Good. Take 180 minus 67. What do you get? 113, is that right?
103. 123.
It's 190.
It's 113.
Got to borrow, right?
Oh, jeez.
17. 17 and 18 are the problems. We're going back over these problems. Shh. Because next chapter is going to deal a lot with these.
That's not even number 17.
Oh, I did draw the wrong one, didn't I? I was looking at, I said 17 and 18, and then I drew the wrong one. What kind of angles are 3 and 4? Complementary, all right? Also next week, along with the chapter 2 test on Tuesday, we will have, you better be perfect. And you're not allowed to sit there anymore. You gotta move to your seat. You wanna move now? Then shh, and focus. They're complementary. Tuesday we have a test over chapter 2. Thursday we'll have a vocabulary test. So make sure you know what complementary, supplementary, all those terms mean. They tell us that angle 3 is 38 degrees. How do we find angle 4 then?
90 plus 38.
90 plus 38?
I don't.
90 minus 38? What is it? 52. Number 18. 18's kind of problem, and both these actually that we'll be doing a lot of next chapter. Angle 7 and angle 8 are complementary. So what's that tell me about these two?
90 degrees.
All right, so I can put like a right angle symbol in there. If I could draw it, my thing's way off. And if those two, is 7 and 8 are complementary, what's that tell you about 5 and 6? They have to be complementary also. They got to add up to 90 also. Angle 5 is congruent to angle 8. Make sure you remember how to mark angles congruent, something like that. Well, we had a theorem last time that said if two angles are complementary to congruent angles, then those two angles must be what? Look back in the book. Flip back a page. Yellow boxes, everybody should be flipping. Look for ones, we're dealing with complementary angles, right? So look for the theorems and postulates we did. It might be 2 pages. I don't know how much you flip back, but there's like 10 theorems.
Vertical angle.
The vertical angle theorem, are we dealing with vertical angles there?
So it's found this one.
It's got to be something about
Angles
complementary.
complementary to the same angle, where two congruent angles are congruent.
So what do we know about 6 and 7 here?
They're congruent.
If these two are complementary, these two are complementary, and 5 and 8 are congruent,
They have to be.
then 6 and 7 have to be congruent. All right? 6 and 7 have to be congruent. So what'd they tell us here? They told us that 6 was 29 degrees. What's angle 7 got to be then? 29. How do you find 5 and 8?
Add, well,
Subtract what?
90 from 29.
90 minus 29. What's that give us? 61. So that means both of them are 61. $19. They tell us that angle 9 is 2x minus 4. Angle 10 is 2x plus 4. What do you know about angle 9 and angle 10? They're what? Which one is it? Supplementary or complementary? Supplementary. They add up to 180. So what equation can I set up?
2x plus 4 plus 2x plus 4 minus 4.
I'm going to solve this real quick. 4x equals 180. Divide by 4. X equals 45. Is that our answer?
Now,
What do you do with that?
plug it,
Plug it back in. What's 2 times 45?
90,
90 plus 4? 94.
86.
86. Those would be your two answers. Make sure you're given the answer that they want. A lot of you read the problem once, you go through and you start doing the work, and then when you get towards the end of the problem, what should you do again? Maybe. You should go back and read the problem. Go back and read and say, hey, all right, what did they ask me to find? Sometimes maybe they'll just ask you to find x. Other times they want you to find the angles. Sometimes they'll just want you to find one of the angles. But you got to go back and read the problem and make sure you know what you're looking for before you start doing a bunch of extra work for no reason. Problem, I'm skipping 20. Let's jump to problem 21. They tell us that angle 13 is 2x plus 94, and angle 14 is 7x plus 49. What kind of angles are those two to each other? They're vertical angles. What do you know about vertical angles?
They're even.
They have to be equal to each other. So what equation am I going to set up here? Equals
7x plus 49.
You got to make sure that you know, hey, am I setting these two angles equal to each other? Am I adding them together to equal 180? Am I adding them together to equal 90? You've got to know that from the information you're given before you go to set up an equation. I'm going to solve this real quick. 45 divided by 5. Is that our answer?
Okay, got plug
Got to plug it in. Does it matter where I plug it in? What do you know about these two when you plug it in? They're going to be the same. So you find one, you pick out whichever one happens to be the easiest for you. All right? Maybe you don't know what 2 times 9 is. Maybe you don't know what 7 times 9 is. So pick the other one. Somebody do it real quick. What do you come up with?
8 plus 94. Top one's 112, bottom one's
Say that.
down.
If the top one's 112, then both of them's got to be 112, right? Does everybody agree with that?
Yeah.
22. Watch on this one. Guaranteed a bunch of you. If I put this one on a test, and I enjoy putting ones like this on test because I know everybody can't do the algebra. 6x minus 290. What equation am I going to set up there?
X equals 6. That's the wrong equation.
Equals what?
6x minus
Now, the reason that people mess up on this one, couple of things that everybody does wrong. What's the first thing we should do here? Subtract 6x. That's where you should start. Bad thing is your algebra teacher probably taught you to always take the smaller x to the bigger x. And if we did that, this is what would happen. And I see people do it all the time. And not only on problems like this, but when you get something like this, what's the first thing you do on that equation?
Minus 2x.
See that? And that's what a lot of people think. They do this. -5. You should get the x's together first. Because when people start moving the numbers around first, then what ends up happening is when they move the variables, a lot of times they'll get everything on one side, and then that messes them up. So and this is the same idea here. If I subtract x, and I end up with 5x minus 290, what happened? There's nothing on the other side. There's no equation anymore. And what ends up happening on a problem like this is about half of you look at it and you go, okay, now I divide by 5, and you end up solving it that way, and there's no equation there to solve because you lost your equal sign, right? So whoever said subtract 6x on both sides was right. If we subtract 6x on both sides, even though it's going to end up with a negative x, we still got an equation. Then you divide by -5. What's a negative divided by a negative? Positive. So those cancel out. How many times will 5 go into 29? 5. With 4 left over, how many times will 5 go into 40? 8. So it might be helpful if you have a calculator if you don't know your multiplication facts, right? Is that our answer? You plug it in. Well, if I plug in right here, which one are you going to plug into?
Either one.
Yeah, it does matter.
The X is A.
I'd plug it in right there. I sure don't want to plug it in there and have to deal with those numbers. Do you? This one's 58. What's this one over here then? 58. Make it easy on yourself. Problem 24. Tried to draw a picture, confuse you a little bit. I think they told you angle 20 is 20x and angle 19 is 100 plus 20x. What do you know about those two angles? They're supplementary. All right, they tried to make it real narrow and stuff, and then maybe you get it confused and think that they're vertical angles. So the equation we'd set up, they're supplementary, then they have to add up to equal 180. We'll solve that real quick. Someday, Jonathan, you'll be able to solve this stuff in your head. Equals 4? Now what do I do with that?
Plug it in.
Plug it in. What's 20 times 2? So that angle's 40. What's this angle over here then? 140. If they wanted both angles, make sure you write down both. Problem 27. The always, sometimes, and never. Watch closely on these. Two angles that are complementary blank form a right angle. Always, sometimes, or never.
Sometimes.
Sometimes. Everybody agree with that?
Yeah.
Now watch, and I'm going to show you why that's sometimes. You could have a picture that looks like this. Angle 1 and angle 2 there. Together they form a right angle. They're complementary, right? Could I have two angles that look like this? Where one's 30 degrees and one's 60 degrees?
Yeah.
And they're complementary to each other? But do they form a right angle? No. So that's why it's sometimes. 28. Two angles that are vertical are non-adjacent. What's non-adjacent mean?
Not next to each other.
Not next to each other.
Always.
Which angles are vertical there?
1, 2, 4.
1, 2, and 4, 1 and 3. Are the vertical angles ever going to be adjacent to each other? No. If they're adjacent to each other, they're not vertical angles, they're supplementary angles or a linear pair, right? So this is always. As a matter of fact, that's the definition of vertical angles is angles formed when two lines or non-adjacent angles formed when two lines intersect or something like that. I don't know. I never cared about that definition as long as you can pick out which ones here are vertical and you know that vertical angles are congruent to each other. 29, two angles that form a right angle are complementary. This top one up here said complementary angles. Does anybody remember back from earlier in the chapter, what's that arrow tell us? Sort of equals, maybe congruent, like implies, right? Tells us, implies, goes to, something along those lines. So in this first one, they said complementary angles mean that you have a right angle. Well, was that always true? No. This one says if you have a right angle, then the two angles are complementary.
No,
So,
sometimes.
so here I have a right angle. They're telling us to start with, remember this is your given part, right? That's what you know to be fact. And then you have it split up into two angles.
Have to complement.
They have to be complementary, don't they?
No.
So, always.
No, I didn't put all of them.
So they're telling you, Grant, that,
I got it.
you sure?
Yeah, I figured it out.
Unlike the first one you knew that you had complementary angles, but that didn't mean that together they had to make a right angle. The second one you start with, you know you have a right angle, and it's split up into two angles. Well, then those two angles have to be complementary always. So when you turn something around, just because it was false the one way, does that mean it's false the other way? No. That was a lot of what we were covering this chapter. Number 30, two angles that form a linear pair are blank congruent. If I got a linear pair here, are those two angles going to be congruent sometimes, always, or never? Sometimes. What would they have to be?
Up, straight up.
So if it went straight up and they were both 90, so that one's sometimes. 31. Two angles that are supplementary or congruent. Same idea on that one. Sometimes. What kind of angles would they have to be? Right angles, 90 degrees again. 32. Two angles that form a linear pair are supplementary. That's always. That, as a matter of fact, that was one of the theorems that we had last time. It said if you have a linear pair, then you know the angles are supplementary. Now, if the angles are supplementary, does that mean we have a linear pair? No, it doesn't work backwards on that one. Because this one says linear pair tells us supplementary, so if we have a linear pair, that means it has to look something like that maybe. But if we know that they're supplementary, then the angles could look like that. They add up to 180, but they don't make a line. Right, this one I would highly suggest that you write down somewhere. This is problem 38, right?
Yeah.
And that next one. We use blazer orange here. If we look this up in my teacher's book, since it's an even number and it's not in the back of the book, the way I'm going to show you to do it isn't going to be the answer that they would have given you in there, but it's gonna be the answer that if we do this exact same problem later on the year, that I would want you to do it anyway, and that the book would want you to do it. So if the book had this exact problem 2 chapters from now in here, they would give a different answer, is what I'm telling you.
Is that W-Y?
I don't know, did I write something wrong? Pen's off, I can't hit the points. First thing we do on this is what? Draw your T-chart?
Yeah.
No. What do you do first?
Fine.
Come over here and label everything and think it through. They tell us that angle ABD, that's that angle right there, is congruent to angle YXZ, that angle. Now that's all the given information. Now you gotta actually use your brain a little bit. Tell me something else that we know in this picture, something that we can come up with on our own.
DBC is complementary to, or it's congruent to.
WXZ.
How do you know that already? We need something else before that.
AC and
ABC.
WY are the same.
ABC and WXY are the
ABC and W, that's true, they're both lines. Straight angles, that didn't really help us. I mean, that sorta does, because that's what, they're what?
I mean, if they're congruent, not as much as congruent, make lines.
But give me a reason why, you can't just say, because I know this is true, that doesn't tell anybody anything. If I did that, if I came in here and taught you every day, and I said, because I said so, that's the way it works. Would any of you learn anything? No. So we gotta think this through and give reasons, so that Sarah knows why it works out that way. Tell me something we know about this picture right here.
It's the same picture as that one.
Nah, don't tell me that. Tell me something we know about that picture.
Supplementary.
DBC.
Go ahead. Go ahead.
Well, it's not right. Well, I know it's right, but it's not what he said. Anyways, DBC is congruent to WXC.
But just tell me something about this picture.
They're supplementary,
Just that one.
What's supplementary?
the whole thing.
This angle and this angle are supplementary. Somewhere in our proof, we're gonna have to say that. Somewhere in our proof, we're gonna say that those 2 angles are supplementary. What do we know about these 2 up here?
Supplementary.
They're supplementary. Somewhere in our proof, we're gonna put that. Now, see what you guys are trying to do, it's like you take an algebra problem. Do you just all of a sudden tell me, yo, x equals 1?
No.
No, it doesn't work that way. You gotta work it out, don't you? You gotta do the steps. Same thing here. You can't just say, well, we know these 2 angles are congruent. It doesn't, you gotta show why. You gotta explain why. Go through and think the problem through and show in a process why that's true. Okay? So if these 2 are supplementary, these 2 are supplementary, then what can we say about these 2 angles?
That they're congruent.
They're congruent because the other 2 were congruent, right? And we just had a theorem. Somebody look up and find the theorem. The theorem that we talked about a few minutes ago was the complementary one, but there's one that goes right along with that said supplementary, right? Who found that the last time? Michael back here found it? The complementary one? So we're going to need that supplementary theorem here in a couple minutes. What's our first statement going to be?
Angle ABD. String graph. YXZ.
How do we know that?
Given
given. As I was walking around looking at your papers, and I looked at Grant's paper, and he just completely skipped number 38. Is he gonna do that on the test? He better not, because right there is how many points? That's 2 points. Regardless, that's 2 points.
Are you supposed to, put a line over?
No, they're angles. They have the angle symbol out front of them. That's all right.
Then you change it to out.
Now, do we need to change this one to algebra form?
Not yet.
Are we gonna add, subtract, multiply, or divide anything? We could. It's a waste of time. We're not going to this time.
Are we gonna say?
All right. Do what?
C and VX.
What did we say next over here?
CBD equals WX.
They were
Supplement.
supplementary.
So that you-
Grant's still wanting to skip that step, even though we thought it through. So if you just say these two are congruent, the next two are congruent, is that gonna tell whoever looks at this next how you got to that?
No.
No, just like in this algebra problem, if you had to work this out, whenever I work out an algebra problem up here for you, I show you the steps, right? And when I show you the steps, does that help you understand how you get from one point to the other?
Yeah.
And that's what we're doing here in this 2-column proof. You're explaining to the next person, hey, how do I go from knowing these two are congruent to the fact that these angles have to be the same? All right, so what are we gonna say next?
Angle ABD.
Angle ABD
DBC.
are what? And I'm gonna write it this way. Angle ABD is supplementary to angle DBC. Yeah, I probably should have. How come I'm gonna turn this around and say CBD? That's the way they named it, all right? Does it matter which way we name it? No, but we don't want to confuse anybody, so if they named it the backwards way, then. Now what? In the same step, what else could I put that's almost identical to this? Angle YXZ, if I could write. Supplementary to WXZ. Now, was that given to us? And what we're gonna put here is, how did you know that those two angles, explain to me how you knew those two angles were supplementary.
Is it like a theorem or something?
Supplementary theorem.
Cause it is. It equals one.
Well, we don't know that they equal 180 because we'd had to say that somewhere in there. But from the picture, we can look at it and see that together they make a what? A line. So we're gonna say something like, and we're just gonna explain it over here. Anytime you're given a reason, this is actually the definition of supplementary angles. Two angles that add up to equal 180, except we don't know that they add to 180, so we're gonna say two angles that add up to be a line. If two angles add to be a, and we could say straight angle, then what do we know about them? Then they are supplementary. Now, what the book actually wanted you to do here is they wanted the step 2 in here, and they wanted you to say that these two angles together form a, or are a, what kind of pair? They're a linear pair. And these two are a linear pair. Then go from there to say that they're supplementary, because then we have that theorem that said if angles are a linear pair, then they must be supplementary. So maybe that would have made more sense here, but I think it's just an extra step for no reason. So now we know that this angle right here is congruent to this angle right here, because that's what we said in step 1. If those two are congruent to each other and they're supplementary to these two, what's that tell us about those two? They have to be congruent, and that's what we're trying to prove. Angle CBD is congruent to angle WXZ. Now, somebody help me out. Now we can use that theorem that they told us last time. What was it? Anybody look it up about 5 minutes ago? And if anybody puts that, I swear to goodness, I'll tear your test up and throw it in the trash and you'll get a 0. If you put given on that last thing down there. Does everybody understand that? Your test will go right in the trash and I'll swear that you never took it and you get a 0. Because, is this last reason here ever going to be given to you?
If it was, why would you do that?
Exactly. If it was, why are you doing this problem? If I gave you an algebra problem and I told you x equaled 3, are you going to do anything else to that? So you're not going to go through a whole process to show me that x equals 3. It was given to you in the first place, all right? So what was that theorem? I don't think it's a supplement theorem. It's the one like Michael read to us earlier. His said something when he read it about complementary angles. This time we're not dealing with complementary.
Supplementary to the same angle or to congruent angles are congruent.
Now, this is what I'm going to write here. I'm going to write the shortened form. Angles supplementary to, this time they're not supplementary to the same angle. They're supplementary to two angles that are congruent to each other. So angles supplementary to congruent angles are congruent. I know that doesn't make a whole lot of sense. So you got to really think about it, right? But if two angles are supplementary to two other angles and those other two angles are congruent, then you know the original two angles have to be the same. Did we prove what they wanted us to prove?
Yeah.
Anything else to do?
No.
No, my proof looks terrible. It shouldn't look that bad. You shouldn't have all that extra garbage in there, but. Does that make any sense?
Yeah.
Great, you gonna be able to do those? You sure? As I look at this, how many points would this be worth on the test? 6. There's 1, 2. Should anybody miss those?
No.
Should anybody miss this one?
No.
That was your proof statement, so they told you what it was. You just had to know how many steps there were in the proof. So you got 3 out of what right now?
6.
You got 3 out of 6, no matter what. It's 50%. Is that better than just skipping over?
Yeah.
Yeah, 50 times better, right?
50%.
Because 50 times 0 is 50 times better, right?
Yeah.
We do that sometimes.
I was hoping you realized it.
We still don't have that problem.
All right, go ahead. What you're going to do, write these down. I'll put it back up here in just a second. Write them down. You might want to skip a line between each one or a couple lines in between each one, and then we'll go over them. All right, on this. Again, I'm going to go over each thing. I'll jot down some quick things for each one. Some of them a little more important than others, so just follow along. Make sure stuff like paragraph proofs down here at number 6. Did we do a whole lot of paragraph proofs?
No.
If I put anything on there about paragraph proofs, it'd probably be something easy, and when we get to that, we'll talk about it. Number 1, a conjecture. A conjecture. What's another word for conjecture?
Conjunction.
Something easy. Just a statement. Conjecture is just a statement. Usually with a conjecture, you come up with your own conjecture if they give you some kind of information, or you take the statement or the conjecture and you tell whether it's what? True or false. All right? So that's another thing. When they say something like truth, when they say truth value, what's it mean when they're talking about truth value?
True or false?
Just tell them whether it's true or false. Don't make it any harder than it is. A counterexample. What's a counterexample?
Proving them wrong.
All right, it's an example
That counts.
that shows a statement is, and I'm not going to say is false, is not always true. Because could the statement still be true for certain things? Yeah, a lot of times things are true for some things, just not true for everything. How many counterexamples does it take to show something is false? One counterexample. One shows it's false. How many does it take to show something's true? All of them. So is it easier to show something's true or something's false? It's easier to show something's false. Conditional statement. What's another name for a conditional statement?
Conclusion. A thesis. Theory.
Boy, I think I remember saying when we first went over that, that was the first question on the final exam.
Oh, if and then.
It's an if and then statement. Conditional statement's also called an if and then statement. The part that comes after the if is called the what? Hypothesis. The part that comes after the then is called the conclusion. Now also through this chapter we went through and we called this something else. The hypothesis, or if we were going to write a 2-column proof, it was the given. And this was the, what else is in the 2-column proof? Proof. So if I made up some conditional statement, if to Tom, then by White. Makes no sense, right? But what's the hypothesis? To Tom. What's the conclusion? By White.
I would've got that one
You would have got that one wrong. Now you'll get it right. Guaranteed there's a few of those on there that says, what's the hypothesis of this sentence? What's the conclusion of this sentence? Truth table. Remember the truth table was that thing? There's no truth tables on there, so I'm not really concerned about it, just so that you've seen it. Negation, what's it mean when you negate something?
Maybe not.
You make it not, or make it the opposite, all right? What's the symbol for negation?
Darn.
Yeah, you'll find out when it comes Tuesday for the test. It's that little tilde. So if you see that, that means not whatever. So if I had that, and then P, what would that say? Not P. What's this symbol? And, thank you. That's the and symbol. And that was for a conjunction. This one was the or symbol, and it was a disjunction.
Are these words gonna be on the, okay.
Maybe. So if I put that symbol on there, on the vocab, and I just have the symbol, you just gotta tell me and.
Is it
Thursday.
Yeah.
So we got and is a conjunction. When you have and, remember we had something like this, P, symbol, not R, whatever, and you had to transform it or translate it into a sentence. You knew what P was, like I think one of them was George Washington was the first president of the United States, and whatever R said, and you had to tell whether this part was true, this part was true, and then decide if the whole thing was true or false. If it's and, what, to be true, what has to happen? Both must be true. So if it's and, both parts have to be true for the whole thing to be true. If it's or, what has to happen? Only one of them. So if one part is true, then the whole thing is true. This one here, pretty important, and the only reason it's so important because there's a couple problems on the test about it, and it's a big part of the test because it takes so much work. What's the converse due to a if and then statement? Switches what?
Doing all, I don't know.
The
Hypothesis.
hypothesis and conclusion. Switches the hypothesis and conclusion. So if I make up some sentence up here, if a square, then 4 sides. Is that true? If you have a square, then it has 4 sides. Yeah.
So it would just be,
What would the converse be?
if 4 sides, then a square.
And then what you gotta do is be able to tell whether that's true or false. So if you have 4 sides, then you have a square. Is that true?
False.
That's false, isn't it?
Because it can be a rectangle.
It could be a rectangle, could be a rhombus, could be whatever other shape. What's the inverse do?
Would just
Makes it not.
I think just switches and negates. Just negates.
Negates both parts. Negates hypothesis and conclusion. Negates the hypothesis and the conclusion. So what would the inverse of my statement up there be? If not a square, then not 4 sides. Is that true or false?
False.
False also, because it could, again, it could be a rectangle. And a contrapositive, what's the contrapositive do?
Switches and negates.
Switches and negates. So what would the contrapositive of my statement up there be?
If not 4 sides,
And then not a square.
If not 4 sides, then not a square. Is that true or false? False?
It's true.
It's true. If something doesn't have 4 sides, can it be a square? No, so it's true. Everybody remember those. Again, this is a big part of the test. Test is only like 20-some questions long. A couple of questions about this. You got to write the sentences out and stuff. That's a bunch of points. So test like 20-some questions long. I think it's worth like 45 points. At least 10 or 12 of those points is right here. So it's like a fourth of the whole test because you got to actually do so much work writing it out and everything and telling whether it's true or false. Number 5, the laws. What 2 laws did we cover?
Syllogism and attachment.
Syllogism and detachment. Law of detachment said, let's go back to that same thing. Square implies 4 sides. Is that true? Yeah, we have a square, we know it tells us 4 sides. Law of detachment says you can take them apart and they'll stand alone, they'll be true separately. So if I tell you then that you have a square, then what can you conclude?
Has 4 sides.
It has 4 sides. Then that's the conclusion, that's the conjecture you can make. Then you know it's got 4 sides. Now what if I changed this and got rid of the square part, and the second thing I said was that you had 4 sides? Could you then say, then it's got to be a square? No, it doesn't work if it goes backwards. All right? Law of syllogism was sort of like what property?
This one.
What did the law of syllogism say?
Oh, that's right.
It is transitive. Sort of like transitive property, only dealing with statements. A implies B, and then what?
B implies.
B implies C, then what can we say?
A implies C.
Then we know that A implies C. So if I say something like a square implies 4 sides, then I say 4 sides tells us that we have a quadrilateral.
Square is what makes it.
Then what can I say from that?
Square.
Square implies quadrilateral. Now again, if it doesn't go in the right order, will it work?
No.
No, it's got to go in that order. Number 6, paragraph proofs. Told you not a whole lot would be on there about paragraph proofs. The one thing that might be on there is what's the other name for a paragraph proof?
Informal.
Informal. It's an informal proof. What's the other name? Let's jump down to number 8. What's the other name for 2-column proofs? Formal proof. Now there will be quite a few questions on there, and that's probably another 25% of the test, or 30%, is the 2-column proofs. There's at least one algebra proof on the test where you're using algebra stuff and using the properties and showing it as a 2-column proof. And then there's a couple of 2-column proofs on the test, so make sure you know how to do those, like that one that we just went over. The last thing down here, the postulates and theorems, you got to make sure that you know, not so much don't have them memorized, but know that vertical angles are congruent. If 2 angles make a linear pair, then you know that they're supplementary, so on and so on. Know all those postulates and theorems. Stuff like 2 points make a what? A line. 3 points make a plane. All right, open up your books to 115. We went 7 minutes longer than I wanted to get. On 115. Yeah, this won't be your homework. On 115, there's those questions. Start working them on the board. For every 5 you get worked up there that's correct, I will give everyone in the class 1 percentage point added to their test.
Everyone?
Yay.
You just said that.
Okay, let's do one up
You have to.
Alright, somebody do one.
Now, I would highly suggest on 115, this isn't your homework, but if you write that down, it would be extremely helpful to study for the test.
Well, and if we get
Like,
115,
Probably made that.
all those.
and if we get February.
Feel like we're not here. Feel like we're not here.
No.
Grab mine.
What is it?
Usually notes.
No, but if I'm not
If you're not here,
Yes, conjecture.
Oh, yeah,
I guess we'll find out. If you're here Tuesday, if you're here on Tuesday and I say, no, you can't use your binders and Michael strangles you, we'll know why.
Well, why do you need to just?
Work, study. Shouldn't have to use your notes if you study right now.
We're already on it. Just make it easy.
It's to stay up there. It's truth value.
What is it?
Truth value.
Also, we get down to the last 5 minutes or so. If there's a problem you know you want to see work off of those
Number
pages,
3 is compound.
I'll work whatever problem because you guys are trying to do the easiest ones, right?
Pretty much.
Number 5.
Is that going to help you with the test?
Yeah.
No.
I think number 5 is
Well,
we're still gonna do number 4.
They'll give you an extra point, but if those are the only couple of points you get for the whole test, then probably not real helpful.
It's and. Fourth one's and. Go to number 5.
Oh, I got all the answers in number 4.
Yeah, go by those. We've had that discussion earlier this year, right?
Hypothesis.
Always go by the answers that some person that had so much intelligence that they wrote in the book told you.
Man, the person that had like.
Is it inverse? What?
No,
They work smart.
This one's postulates, right?
Oh, yeah. Yeah, positive.
Number 8, did we get 5 right there?
Yeah.
Informal.
A is
What?
A is informal.
Informal.
You guys are saying, he said we haven't got to the point.
Yeah, we have. He said yes, it should say up and down.
He hasn't said
Just look at
nothing.
me and keep going.
Number 8 was informal.
No, we're not.
I know I'm pretty, but you need to be.
9 and.
Yeah.
Pretty ugly.
Oh, which one?
Just kidding, Mr. Eversol, don't count a point off.
I was gonna say, that's helping your test grade.
What is it?
Make a conjecture based on the given information. Draw a figure.
Okay,
to
put
illustrate.
angle A and angle B equal 180 degrees. That's your conjecture.